Okay. Now we are starting from the last lecture, that how to check the normality of the data set. And because I want to again remind you about the normality structure and how to check the normality of your data set, because it is the important part of your data analysis. How to check the normality? The normality can be checked through different measures. The first one is draw the histogram on and draw the normal curve on it. And the second one is on the basis of skewness and kurtosis. If your values of skewness and kurtosis lie between -2 to +2, then you can say that your data follow normality. But the problem is that I also told you yesterday that the problem is the reviewer or someone not satisfied properly once you are not performing the normality test. So according to normality test, to check the normality of your data, you can apply the KS test or Shapiro-Wilk test for the normality testing of your data. How to perform the Shapiro-Wilk test and Kolmogorov-Smirnov test, that is known as KS test, and Shapiro-Wilk test as W test. So these two tests are used to analyze the normality of your data set. How to check the normality of your data set? Just again, we can see this as this is your data set as we discussed the yesterday. Just go to analyze, go to descriptive, go to explore, and you are interested, suppose you are interested in health score, you are interested in average score, and you want to check these two variables, they are normal or not. Then go to statistic, you are interested in descriptive, click on OK. Again, click on plot. Plots, just unclick the stem and leaf. Just unclick the stem and leaf and click on normality plot with test. Continue and click OK. Then in output window, just go to the top and second last column is output. Just click on output and you get that the health score. This is the descriptive of your data, health score and average score, because you are interested in these two values. There is no missing values in your data set. Total 25 values are there. Health score, descriptive statistics, skewness 0.464, kurtosis 0.902, both value lies between -2 to +2. We can say that on the basis of this your data follow normal distribution. But you are interested to tell that your data normal through some by using some testing, by using some p-value. So on the basis of test for the normality, you have performed the Kolmogorov-Smirnov test and Shapiro-Wilk test. So health score, this SIG value, that is 0.200. That is this is your p-value. When we perform KS test and when we perform Shapiro-Wilk test, Shapiro-Wilk test basically for small samples and Kolmogorov-Smirnov test for large samples. So large or small samples के लिए we can use for KS and Shapiro-Wilk test. So here both p-value, SIG value means p-value. P-value, both the SIG value, Shapiro-Wilk test 0.139 and KS test 0.200, both p-values is greater than 0.05. 0.05 is nothing but alpha. Alpha is when you start your question, you fixed your alpha probability or level of significance, that is 0.05, and p-value is greater than 0.05. So we accept that our data follow normal distribution. Your hypothesis is your data follow normal distribution, and alternative is your data does not follow normal distribution. So p-value is greater than 0.05 because 0.139. This p-value is greater than 0.05. So we can say that the hypothesis accepted and data follow normal test. So after this, after check that that your data set normality conditions, and after then ANOVA test and basically parametric test you can easily perform after fulfill the condition of the normality. तो आप नॉर्मेलिटी कंडीशंस जब फुलफिल हो जाएंगी तब हम पैरामेट्रिक परफॉर्म कर पाएंगे पैरामेट्रिक टेस्ट को, अदरवाइज वी कैन परफॉर्म द नॉन पैरामेट्रिक टेस्ट. सो हियर health score, all the variables, health score and activity score, average score follow normality, so we can perform parametric test. So the first thing in data analysis is descriptive statistics and inferential statistics. So descriptive statistics contains mean, median, range, standard deviation, and graphical representation like histogram, par, by, scatter. So these are the come in the category of descriptive statistics. While in inferential statistics, estimation, hypothesis testing, both are come in the category of inferential statistics. So first we start from the descriptive statistics. How to get the descriptive statistics of your data set? Descriptive statistics, for your descriptive statistics, go to analyze in SPSS window, then go to descriptive statistics and click on descriptive, and move all the variables in a variable window and click on desired, click the desired statistics and then click OK. Now come to the SPSS file. This is your SPSS file. You are interested in descriptive of your data set. Go to analyze, go to descriptive, then again go to descriptive. Once again, go to analyze, go to descriptive, then again you saw the different options are there. Just click the second option, that is descriptive. Click on it. You are interested in the descriptive statistics of gender of a person. You are interested in health score. You are interested in monthly income. So these are three variables. Suppose you are interested, then click on options. You are interested in mean. You are interested in SD minimum. You are interested in kurtosis, skewness. Click on continue. Then click on OK. After that, here we can see this as this is the descriptive of your data set, means descriptive statistics. आप ये देख सकते हैं यहाँ पर, you can see this as gender of a person, total 25 values. All variables have 25 values. No values are missing. So gender of a person 25, minimum value is 1, maximum value of a gender of a person is 2, because 1 and 2, there are two only genders participated in your questionnaire. Mean statistics 1.4, standard kurtosis, skewness. So these are the descriptive statistics in which you are interested, and these are the descriptives of your interested the variable in which you are interested. You are a gender of a person, you are interested in health score, monthly income. So you can easily achieve the descriptive statistics by using this command. Go to analyze, go to descriptive, and again go to descriptive and click on the suitable entities, particulars in which you are interested. Click on it. Go to continue, go to again continue, and you get the descriptive of your data set, descriptive of your variables in which you are interested. Now again, next thing is, suppose you are interested to add two quotients values, or you are interested to make new variables by adding two different variables. Suppose आप interested हैं कि we are interested in adding two values in SPSS, adding two values and make new variable. Then how can we perform new variable? How can we transform these two values in a single new variable? तो इसको कैसे? Just click on transform and compute. Click on transform and compute. Just second one, type the name of the variable. This is the screenshot of the window when we run on the SPSS. This is the target variable, and you can write the target variable, write the naming of the target variable. Suppose O health, new variable name. What type? Numeric expression. You are interested in health score plus personality score divided by 2. You want to make the new variable. Just click on it, numeric expression, and click on OK. You now go to transform and compute. Now come to the SPSS file. Just click, just saw that fifth on the upper top, you get the fifth transform. Fifth column, fifth section is based on transform. Again, file, edit, view data and transform. You can click on it, transform. Just click on it, transform and compute variable. Click on transform and compute variable. So just click on transform again, then compute variable. Target variable, you are interested in making new variable. Suppose just write new. You are interested in new variable. So suppose you are naming as a new, just hypothetical name, and you want to add this by, you want to make this variable by adding two different variables. This is the, suppose you are interested in health score, you want to add health score, this one health score, just click on it, and you want to add plus personality score, click on it and just click on OK, and just go to the window, your data window. You can see this as new. Just see new as your new column. How can you get this one? By transforming, by adding these two values in a new variable, HS plus PS. These two sections you can add it and make a new variable, new as a as generate a new variable. 22.54 plus 15, that is 37.54, and you can get the transform the variable to new two variables HS plus PS and generate a new variable by using the command transform. Just go to transform and go to compute variable and make the new variable in which you are interested. So you can use whatever, you just divide or add or subtract and multiply. You can transform the values in a new variable by using the command transform. So again, next thing is hypothesis testing. This is the most important part of your data analysis. Hypothesis testing, there are two types of hypothesis in your survey questionnaire: the null hypothesis and alternate hypothesis. Null hypothesis means hypothesis to be tested, and alternate hypothesis, basically alternate hypothesis is your research objective, hypothesis of research. Yani means you have to show very sure once before making your questionnaire. Once your objective is clear, then you can easily make your hypothesis. Otherwise, if your objective is not clear, then it is difficult to make the hypothesis. And once your hypothesis is not clear, it is also create problem in the data analysis. And generally ये problem होती है कि which type of test we use, which type of pie chart or graph pie chart, and how to use pie chart, how to use a bar chart when your objective is not clear. When we use the pie chart, pie scatter diagram, and other thing, many more things, once your objective is not clear, it is also create problem in the analysis part. So you have to make very clear in the objective section. So objective is clear, then your hypothesis will also clear, and then you can easily apply the test once your hypothesis is clear. So there are two types of hypothesis. One is null hypothesis and the second one is alternate hypothesis. Null hypothesis, hypothesis to be tested, means someone said that there is no significant difference between these two groups. So null hypothesis means there is no significant difference, and the alternate is there is a significant difference, or someone is superior or someone is inferior. So this comes in the category both are not equal also. So this is the category of alternate hypothesis. So the important thing is you have to note that the alternate hypothesis basically is the hypothesis of research. जो आपकी objective होगी, basically this is your hypothesis of research, that is your alternate hypothesis. Hypothesis, that is always two types: HA, research alternate hypothesis. What we aim to gather evidence of, typically that is there is a difference, effect or relationship, etc. And as I told you that H naught is also explained in terms of H naught, that is null hypothesis. What we assume is true, means hypothesis to be tested. typically that there is no difference, effect or relationship, etc. So once you form the hypothesis, then after that, suppose you want to perform t-test. So there are three different applications in t-test. T-test for single mean, t-test for two independent sample t-test, and pair t-test. So first we perform t-test for single mean. Suppose you have a question that average health score of a normal person is supposed to be 55. Health score of 12% from a community whose living conditions are suspected of causing poor health. Score are recorded in health data file. Do the data justify that suspicions regarding the health score of the community using level of significance 0.05? So H naught is average health score of a normal person is 55, and HA is average health score of normal person is less than 55, because you know that suppose in according to question your average health score is 55, but once 12% of your community provide better living conditions, and we saw that once we get the better living conditions, their health score will be better. So alternate hypothesis, your hypothesis of research is average health score of a normal person is less than 5 because they residing in the poor living condition. And alternate your null hypothesis is no, average health score of a normal person is 55. Your value is given. So before performing t-test, first you have to check that data follow normality or not. तो सबसे पहले आपको चेक करना पड़ेगा that data follow normal or not. So of interest. So first you have to check that data follow normal or not. Just go to analyze, and you are interested in health score. Just click on, just see this. Go to health score data is normally distributed or not. Then analyze, compare mean, and one sample t-test. Just go to this one. You are interested in health score. Just click on it, health score. Go to plots, and you are interested in normality plot with test to check that your data, health score data is follow normal or not. Go to OK. And we see this as here, health score data. Just see it, health score, the as Shaprovik's value is 0.139. The p-value is greater than 0.05. So we can say that your data follow normality condition. If H naught is accepted because p-value is greater than 0.05, so we can say that your data follow normal distribution. After that, we can easily perform the parametric test, t-test. So now we are able to perform the t-test. Agar ye nahi hota, then we cannot perform the parametric test or t-test. So your data is normal, then further proceed for the t-test. Now go to analyze, go to compare means, and here you get one sample t-test. Go to analyze, go to compare means, and go to one sample t-test. Your test variable is health score. Your health score is your testing variable. And what is your testing value? Just see the health score hypothesis. Average health score of a normal person is 55. Your test score, because you are comparing with the value that is 55, and you are saying that average score of a normal person is 55, but hypothesis of research is no, it is less than 55. So 55 is your testing value. So you can write it in the section of test value 55. Put out here 55. Click on OK. Now we can see this as health score, one sample t-test. So health score is 0.021. This is the p-value of your data set. P-value of your data set. So p-value gives you 0.021, which is greater than alpha, that is 0.0. We can see that p-value is less than 0.05. 0.05 is greater than here alpha is greater than this your p value, and here sign significant value is two-tailed, but your alternate hypothesis is less than. Less than means one-tailed. If your hypothesis is less than or greater than, then your hypothesis is one-tailed. Your hypothesis will be one-tailed. If it is like not equal to case, means average health score of a normal person is not equal to 55, that in this case your p value will be your hypothesis will be two-tailed. So once you are not able to know that your hypothesis, alternate hypothesis, is less than or greater than, then it will be your two-tailed hypothesis. And once it is clear that it is less than or greater than, then your one-tailed hypothesis. Then here in your question, a hypothesis will be less than 55. That means your alternate hypothesis is two-tailed. So here we can see that significant basically one-tailed. So significant value is two-tailed here. So you can divide this p value divided by 2, and you can check if p value is greater than 0.05, we can reject the null hypothesis, and if p value is less than 0.05, we can if p value is greater than 0.05, we can accept the null hypothesis. If p value is less than 0.05, we can reject the null hypothesis. So if we divide this 0.021 divided by 2, because your hypothesis is less than, that is one-tailed, so then you can divide it, significant p value divided by 2. तो 2 से डिवाइड करेंगे और देखेंगे कि ये जो वैल्यू आएगी that will be less than 0.05. So we reject the null hypothesis, and reject the null hypothesis means you can reject this statement, reject the null hypothesis, you can reject this statement, and we can easily say that average health score of a normal person is less than 55. So after that you can further proceed for the sample t-test. How to check the if you have two different populations, suppose independent sample t-test, independent sample t-test when you have two different groups on a particular data. Suppose with reference to our health data, suppose we wish to test is there any significant difference between mean health score of a males and females. Means here you have two different populations, male population and female population. There are 25 values are there, male for 14 and females are 11. So you have already noted the health score of males and females. Just so here you have two different populations, male and female, and you want to compare that there is any significant difference between males and females with respect to average health score. And alternate null hypothesis क्या होगी आपकी, what will be your null hypothesis? There is no significant difference between male and female with respect to average health score. So here you have two different populations, so we perform independent sample t-test. So before performing the independent sample t-test, just check that your data follow normality or not. Normal follow कर रहे हैं या नहीं कर रहे हैं, तो normality will be checked by the same command. Just go to the analyze, go to the descriptive, and go to explore and click on normality plot with test. And after checking that they follow normal or not, और हम देख चुके हैं, we already know that health score already follow normality, so there is no need to perform here again. Just go to analyze, whatever be your variable, just go to analyze, go to descriptive, again go to explore and click on normality plot with test and click on it. Then you get that your data follow normality or not by according to KS test or Shapiro-Wilks test. Now how to analyze the independent sample t-test? Go to analyze, go to compare means, independent sample t-test, move health score because your variable of interest is health score. Then you get the defined groups, column is also there. Group 1 is 1 for male and 2 for female, and click on OK. How can we get on SPSS? Just go to analyze, click on analyze, go to compare means, and you are interested again. There are so many options on the right hand side, but you have to click on third one, independent sample t-test. Just click on it. You are interested in health score. Just click on, it comes in the category of testing variable. Now grouping variable. What will be your grouping variable? Your grouping variable is gender of a person, because on the basis of gender means you are interested in, is there any significant difference between male and female with respect to health score? So there are two different population, male and female. So gender, you can, here you see that the question mark is there. What will be the grouping name? 1 for male and 2 for female. Click on continue. Again, suppose reset it. What is your testing variable? Health score. Click on it. Then what will be your grouping variable? Because your population is male and female, and you are getting that which one is group? 1 for male. Sorry, 1 for male and 2 for female. Click on continue. Click OK. Here there are two different populations. Male, 14 males are participated in your questionnaire. 11 females are participated in your questionnaire. And we see that the health score, this is the independent sample t-test. Independent sample t-test. On the basis of this table, you can easily interpret the hypothesis. So before going to the main p-value, just check that this significant value, health score equal variance assumed, because in t-test your Leavenet test of equality of variance must be checked. If this value, if this Leavenet test value equality of variance is greater than, if this p-value is greater than 0.05, then we can perform the further proceed for the independent sample t-test, otherwise not. Then here Leavenet test for equality of variance, because for t-test Leavenet test is very important. Equality of variance assumption is very important. And here Leavenet test for equality of variance is p-value. Sig value is p-value. P-value is 0.219 and it is greater than 0.05. So we can say that your health score data equal variance assumed to be test for equality of variance is this one is fulfill the condition. Now come to the independent sample t-test significant value. That is significant value two-tailed. Why it is two-tailed? Just go to the hypothesis. Just saw two-tailed, by default it takes two-tailed, but just saw the hypothesis. Your hypothesis is there is significant difference between male and females, and it is not clear that the average health score of male is superior or female is superior, or which one is inferior or which one is superior. So once it is clear, then it will be one-tailed, and once it is not clear, there is significant difference, means it is not clear from the alternate hypothesis that which one is which one have good average health score, male or female. It is not clear here, so there is a case of not equal. So here it is two-tailed. So in this case, your significant value is two-tailed. No need to divide it. Your two-tailed alternate hypothesis 0.944. 0.944. So here, what will be your hypothesis is accepted or rejected on the basis of this value? Can anyone tell me this on the basis of two-tailed 0.944? Your hypothesis accepted or rejected? 0.944. Yes. Anyone? Can anyone tell me that your hypothesis 0.944 hypothesis accepted or rejected? Yes. So 0.944. 0.94. So rejected. So 0.944. No. 0.944 p-value is greater than 0.05. If p-value is greater than 0.05, just write it. If p-value is greater than 0.05, then we accept our null hypothesis. Otherwise, we reject. Just note down the statement that if p-value is low, null has to go. So here p-value is low, null has to go. But here p-value is greater than 0.05, your level of significance, 0.944. So you can accept the null hypothesis. Accept means you are accepting this statement: there is no significant difference between the population of male and female with respect to average health score. So this is the interpretation of the independent sample t test. Next thing is very important is paired t test. Paired t test, as far as name concerned, your data will be in pair. But uh, pair t test and independent sample t test, how can we differentiate these two tests? In pair t test, your population will be same, your sample will be same, and in independent sample t test, your population will be different. And you saw that independent sample t test, your male and female health score means your population is different, male and female. In pair t test, your sample must be dependent. Why it is say dependent? Means it is based on before and after test. Suppose you note down the health score of 12 patients, and you note down it, and after that providing the co-vaccines, after providing the vaccines on these 12 patients, and after providing, you can note down the condition of the health score, and you can note down. So your patients will be same. So pre and post, before and after, in these conditions we perform the pair t test, and your sample must be dependent. And in independent sample t test, your population is different. In you saw that population is male and female, but in pair t test, your sample will be same in both the cases, pre and post, and after, before and after. So pair t test is different because of the sample are dependent. So please refer to the health score data. This is the question. Refer data whether it seems that poor living condition is one of the cause for poor health score. Better living conditions are provided to the people of this locality, and after a month again their health scores are recorded. Now we want to test, is there any improvement in their health after providing better living conditions? Means first we note down the according to locality, we note down the health score, and after that we provide the same persons to the better new locality, and we provide the better living conditions. So just want to check there is any significant difference in the health score after providing the better locality on the these 25 persons. So what is the null hypothesis? There is no significant difference between the mean health score before and after providing the better living condition. And alternate hypothesis is yes, there is a significant difference. So you are interested to check, and you know that there is samples are dependent here. Before and after, in both the cases, your sample will be same. So pair t test, how to perform the pair t test? Before performing any type of t test, because it is parametric t test, and parametric test, just check the normality of your data set. Your health score, check the health score, and health score 1 as a check the normality of your data set. Then again click on analyze, go to compare means and paired sample t test, move health score under variable 1 and health score 1 as a variable 2, and click on OK. Now come to the data set, go to analyze. We are not going here to check the normality, because we already know that how to perform the normality to check the normality of your data set. Just go to analyze, go to descriptive, and go to explore, and you are interested in health score and new health score. Click on plot and go to normality plot with test and click OK, and you can get it here, the normality test. Here we can say that health score test of normality is 0.139, and new health score we can see that 0.489. Both p-value is greater than 0.05, so we can say that both the variables, health score means before health score, this is the health score is before providing the better living condition, new health score after providing the better living condition, and your sample will be same, 25 sample. So here both p-value is greater than 0.05, so we can say that our data follow normality condition. Then now we are further proceed for the pair t-test. Go to analyze, again go to compare mean, again go to paired sample t-test. Just click on paired sample t-test. Again, just see, analyze, go to compare means, again go to paired sample t-test. What is your first variable is health score, that is your before health score, and average health score, sorry, new health score, that is your new health score after providing the better living condition. And you want to check that is there any significant difference after providing the better living condition. Just click on continue, click on OK. So here we can see this, see that this one paired sample t-test, you see it here, significant value is 0.028, means 0.028, your two-tailed hypothesis, 0.028, p-value is greater than p-value is less than 0.05, less than 0.05, that means alpha is greater, 0.05 is greater than your p-value. So we reject the null hypothesis. Reject the null hypothesis. What does it mean? It means that you reject the null hypothesis. You are rejecting this condition. You are rejecting this statement. And you can say that there is a significant difference. Means if we provide the better living condition, then their health score will also be improved. Means कि अगर आप उनको बेटर लिविंग कंडीशंस प्रोवाइड करते हैं तो उनका हेल्थ स्कोर भी इंक्रीज होगा. बेटर लिविंग कंडीशन अगर आप प्रोवाइड करेंगे देन इट विल इंक्रीज द हेल्थ स्कोर. तो इस तरह से हम पेयर टी टेस्ट परफॉर्म कर सकते हैं. नेक्स्ट थिंग इज कोरिलेशन एनालिसिस. व्हाट इज कोरिलेशन? Basically, correlation measures how variables are related, or the correlation coefficient is used to quantify the strength of the linear relationship between two variables. Basically, correlation measures strength and direction of the two variables. Strength and direction, how two variables are related with each other, and what is the direction. Direction means positive or negative. And what is the range of correlation coefficient? Correlation coefficient means range of correlation coefficient is -1 to +1. Correlation values lie between -1 to +1. If value close to +1, then we can say that the variables are positively correlated with each other. If there is a negative values, means 0.6, 0.8, 0.7, -0.7, -0.8, -0.9. So we can say that negative correlation between these two variables. Positive and negative correlation means, positive correlation means both variables moves in the same direction, deviate in the same direction, and negative correlation means both variables moves in the opposite direction. Suppose income and expenditure, X is your income and Y is your, suppose 10 values for income and Y values 10 values for expenditure, and income and expenditure, these two variables, and you want to know how these two values are correlated with each other. So we can say that this is the example of positive correlation, income and expenditure. When income increases, expenditure also increases. And similarly, we can say that we can consider the example of health score and age. So this is the age and health score. Age and health score, this is the example of negative correlation. Once age increases, your health score decreases. जैसे जैसे age बढ़ती है, आपका age health score भी कम होने लगता है. तो there is a negative correlation. So this is there are two types of correlation, negative and positive correlation. Negative means positive, both moves in the same direction, and negative means both deviates in the opposite direction. And Spearman-Kendall correlation coefficient, both are used for non-parametric measures. Basically, it is used for ranking and Likert scale. When you have ranking or Likert scale, we can perform the Spearman and Kendall correlation coefficient. How to perform the correlation coefficient? Suppose in health data file, graph the data in a scatter plot to determine if there is a possible relationship between age and health score. Suppose you are interested in age and health score to check this, is there any correlation between age and health score? How to calculate, how to perform, how to obtain the correlation between age and health score? Just just go to data set, go to analyze, go to correlate, go to bivariate. Bivariate means two variables. And you are interested in age of a person. You are interested in, is there age, is there age of a person and health score is correlated with each other or not? And if they are correlated, then which type of bonding is here? So click on health score. These two variables, you want to check that there is any correlation or not. By default, it consider Pearson, because you are interested in Pearson correlation coefficient, Carl Pearson. So it is based on his name, Carl Pearson correlation coefficient. Just click on it, okay. And you can see that age of a person and health score, this is minus 0.684, that is nearly minus 0.7. If it is close to -1 means -7, above than -0.6, -0.6, -0.7, -0.8, -0.9, this is a strong negative correlation. If it is close to +1 means 0.6, 0.7, 0.8, 0.9, we can say that a strong positive correlation. So we know that health score and age score, this is the negative correlation. This is the perfect example of negative correlation. And we know that as far as age increases, health score becomes decrease. तो जैसे जैसे एज बढ़ती है, हेल्थ आपकी डाउन होती रहती है. तो एज एंड हेल्थ स्कोर गिव्स यू द -0.684. दिस शोज दैट एज एंड हेल्थ स्कोर there is a negative correlation, strong negative correlation between age and health score. तो आप इस तरह से देख सकते हैं कि age and health score में strong negative correlation है. तो किसी भी variables के बीच में आप यहाँ पर find कर सकते हैं. Now next one is partial correlation. What is partial correlation? Partial correlation coefficients describe the relationship between two variables while adjusting the effect of one or more additional variable. Just consider the example. If you want to know the effect of two variables by controlling the effect of third variable, we use the partial correlation command. So just consider the example, sale, production and purchase, sale, purchase and production. So these are the, suppose you are interested in sale, you want to know the sale and production, you want to know the correlation between sale and production, but purchase is also affect these two variables. So you can here calculate the sale correlation between sale and production by controlling the effect of third one. Kaise control? Suppose you consider the example. Suppose you want to find the correlation between health score and personality score by controlling the effect of age, because age also affect the health score and age also affect the personality score. Both two variables affected by age. So we consider the controlling effect as a age. You want to compare, you want to know the correlation between health score and personality score by controlling the effect of age. How to calculate? Go to analyze, go to correlate option, go to partial and click on it. Variables are health and personality, controlling effect is age, and click on it. How to get this value? And health score, personality score and age. Just go to analyze, go to option correlate, go to analyze, go to option correlate, go to partial, and your variables in which you are interested to find the correlation, health score, click on it, personality score, click on it. By controlling the effect of age effect को आपको use करना as a controlling effect. Click on it, okay, and you can say that the correlation is a very rare correlation. Age of a health score between correlation is 0.007. It means very weak correlation between health score and personality score, that is 0.007. 0.007 means nearly zero. That means there is no correlation because it is hypothetical data. So once you perform on your survey, it will provide you the better result. So this is just for your example. 0.007. 0.007 means very weak correlation. Very weak correlation means there is no, or you can say that no correlation. 0.007 means 0.01. So there is no correlation. It seems that there is no correlation between health score and personality score by controlling, once you controlling the effect of age. So this is the example of partial correlation. Now, most important thing is comparing means using one-way ANOVA. One-way ANOVA. ANOVA means analysis of variance. When we use analysis of variance, what is the when we use analysis of variance, and what do you know about the analysis of variance? Means to check the significant difference between means, more than two means. यानी significant difference between means अगर हमें check करना है, then we perform ANOVA. Full form of ANOVA is analysis of variance. Comparing means if you have more than two groups, then we perform ANOVA. For two groups, we can easily perform independent sample t-test, but here you have more than two groups, so we can perform ANOVA. So just using the example, in reference to the health data file, suppose a researcher wish to test is there any significant difference in the mean health score of a people belong to different income groups. Here it is based on income groups, and you want to check the health score of different income groups. Different income groups आपने कल देखा था, you can yesterday we saw that we have different age different income group. Just see in the variable view, your monthly income is divided in four groups: 0 below 2000, 1 whose salary is 2000 to 4000 coded as 1, 4000 to 8000 coded as 2, 8000 to 10,000 coded as 3. So here there are four different groups, and you want to check these four groups, is there any significant difference in health score of these different income groups of a person. Means कि जो इनकी incomes हैं उनके according क्या उनके health score में भी फर्क है. Is there any significant difference according to the monthly income? And we perform, there are four groups, more than two groups, so that's why we perform the ANOVA. So here H naught null hypothesis is mu naught. Mu naught means first group, mu 1 is the second group, 1 means 2000 to 4000, mu 2 means third group, 4000 to 8000, mu 3 is the fourth group, that is 8000 to 10,000. Mu naught, mu equal to mu 1 equal to mu 2 equal to mu 3. Your null hypothesis is there is no significant difference between the different income groups with respect to average health score. Means कि according to income there is no significant difference in the average health score. But alternative said that yes, at least one group significant is at least one group is different. नहीं, उनके एटलीस्ट एक ग्रुप में उनके लाइफस्टाइल में एवरेज हेल्थ स्कोर में फर्क आएगा. ये हमारी अल्टरनेट हाइपोथेसिस है. तो फर्स्ट यू हैव टू चेक बिफोर परफॉर्मिंग एनी पैरामेट्रिक टेस्ट, एंड ANOVA comes in the category of parametric test. First you have to check on the basis of monthly income, check that the health score follow normal or not. So then normality check, your commands will be same. Go to analyze, go to descriptive, go to explore, and click on normality plot with test, and you can check through KS test and Shaprovic's test. आप इस तरह से check कर सकते हैं. Then go to, once you check that your data follow normal, then go to analyze, go to compare means, and go to one-way ANOVA. Click move health score as a dependent list and monthly income into the factor box, because you are making the groups on the basis of monthly income. Just click on it, just check. Go to analyze. Sorry, your data is here. Go to analyze. We know that our health score follow normal distribution, not normally distributed, so no need to perform the normality test. just go to compare means, go to analyze, go to compare means, and go to paired one way ANOVA. Go to analyze, go to compare means, go to one way ANOVA, and your variable of interest is health score. Click on it in the dependent list. What is your factor? Factor is your monthly income. You are making group on the basis of monthly income. Go to post hoc test. When we perform post hoc test will be performed when your null hypothesis is rejected. अगर आपकी null hypothesis reject हो जाएगी, then we can perform the post hoc test, because post hoc test is based will tell you that which group is responsible for the variation in your health score, which group is responsible for the rejection of your null hypothesis. So once your hypothesis is accepted, then no need to perform the multiple post hoc tests. There are so many tests are available, but you can perform Tukey test. Tukey test, by using the Tukey test, you can perform to check that is there any significant difference. But point to be remembered that once your hypothesis is rejected, then it will be useful. Your post hoc test will be useful. Otherwise, if your hypothesis is accepted, then no need to perform post hoc multiple comparison test. Just click on continue, and options, click on descriptive, homogeneity of variance test, click on continue, and click on OK. And here we see that this is the descriptive of your different monthly income groups. There are 4 groups. Mu naught is below 2000. Similarly, mu 4 is 8,000 to 10,000. So mu naught, mu 1, mu 2, mu 3. And you want to check, is there any significant difference between these 4 groups on the basis of average health score? Your health score, homogeneity of variance, because homogeneity of variance is very important, and Levenet test, as I already told you in the previous test, that Levenet test statistics must be fulfilled, that is 0.147, and p value is greater than 0.47, and we can say that you are able to proceed further. Now this is the ANOVA table, and ANOVA table on the between groups, you can see that the F value is 0.1.183. This is sig value, that is 0.34 value. This p value, just see the ANOVA and you can check the p value 0.340. On the basis of monthly income with respect to health score, you get p value is 0.340, means p value is greater than 0.05. P value is greater than 0.05 means you are accepting the null hypothesis. Accepting the null hypothesis, because your p value is greater than 0.05, means you are accepting this statement. Accepting this statement means there is no significant difference of between the mean of health score with respect to monthly incomes. The groups of monthly income means below 2000 monthly income up to 8,000 to 10,000 monthly income, there is no change in the average health score. So as per data, we can say that there is no significant difference between the monthly average health score with respect to the different monthly income groups. So there is no need to perform the multiple post hoc test. Once we rejected, then you can perform the post hoc test, because you can get that which group is responsible. But as I click to tell you that, just see it here, 0.34 already accepted, then no need to perform post hoc test. But I will tell you here, just see it, group wise comparison below 2000 to 2000 to 4000. Here we check the p value is 0.899, which is greater than 0.899, so it is accepted, means there is no significant. You can get 0.357, means already accepted, there is no need to check further that there is no significant difference. Below 2000 to 8000 to 10,000, 0.5229, it is also already p value is greater than 0.05. So here all values are greater than 0.05, and already here 0.34, no need to perform the post hoc test once your ANOVA will be accepted. So there is no significant difference between the monthly income groups with respect to health score. So this is the concept of ANOVA. So in ANOVA, first you have to check that your data follow normal. Then after that, check the Leavenworth test, equality of variance, homogeneity of variance. Then if your hypothesis accepted, then it is okay. No need to find, no need to proceed further. If it is not, then check the multiple comparison test, means group wise comparison test, and perform two key test to check that is there any significant difference between the groups. So this is the brief concept of ANOVA. Now next thing is simple linear regression. Simple linear regression means regression analysis is used to predict the dependent variable on the basis of several independent variables. Means regression analysis basically to tell you to predict, basically it is used to predict the dependent variable on the basis of several independent variables. Suppose if you have a single dependent variable and single independent variable, only one dependent variable and one independent variable, then it will be the case of simple linear regression. If your dependent variable is suppose if you have more than two independent variable in your model or in your analysis, then you have to perform the multiple linear regression analysis. So simple linear regression analysis refer to the health data file, measure the degree of attachment of age and health score variables, and check whether linear regression is possible or not. Means we have to check that is there any association between age and health score. Correlations tells you that age and health score, how what is the strength of age and health score, how the values are related. But regression talks about that how these two variables how much these two variables are associated, because it is based on modeling. What is the unit impact of age? One health scores already what is the impact of health score when age increases, unit effect of age increases. So this will comes in the category of regression analysis. So just check before performing, just check the correlation between age and health score. तो already हम check कर चुके हैं age and health score को. Then how to check the regression analysis in SPSS? Just go to analyze, go to regression, then go to linear. Then just click on your dependent variable is health score and independent variable is age of a person. And after that you get this section. Select estimate, just click on statistics and you get estimates. Click on it, confidence interval, model fit, because you are interested in model fitting. And just click on plots. No need to change anything. Just click on normal probability plots. Then click on unstandardized and studentized. Just click on it and you get this model summary. And basically it is important because beta naught, y is equal to beta naught plus beta 1 x1, because your x1 is the independent variable and y is the dependent variable. If your variable increases, means your model will be y is equal to beta naught plus beta 1 x1 plus beta 2 x2, means there are two variables. Then you perform the multiple linear regression test, multiple regression analysis, and adjust R square value is very important. R square value is coefficient of determination. If your R value is close to 1, that is 0.748 R square or adjusted R square, you can use it here. 0.722. 0.722 means 72% variation explained by the model, means 74 point. Suppose if you are considering 0.748, 74.8% of the variation of the health score data is explained by age. Yani if your model explained more than 60%, then you can say that your model will be good fit. Then your health score explained by the nicely explained by the age. 74.8% of the variation in the health score is explained by the age, that is more than 60%. So you can say that, yeah, your coefficient of determination, that is R square, is greater than 0.6 or 60%, then your model will be good. So in testing, how to check that, how to perform the regression analysis, go to analyze, go to regression, and go to linear regression. What will be your dependent variable on the basis of quotient? Just see the quotient. Quotient will be, quotient is here the age and health score. Your age is independent and health is dependent. Just click on it. Age, what is health score is dependent variable. Age of a person is independent variable. Go to statistics, estimates, model fit, confidence interval, click on it, click on OK. Plots, normal probability plots, continue, and click on OK. And we see that your value is, just see it here, your value is adjusted R square, this one. So that this is the 0.684. 0.4 adjusted square is 0.44 on the basis, because this is hypothetical data, that is 0.444. So this is the coefficient of determination. So on the basis of evidence, we can say that this model is not fitted well, because if your value is more than 50% or more than 60%, then you can say that your model fitted well, your model this model explained properly. So here 44.4% of the variation explained by the model, which is less than 0.5, 50% or 60%. So it is on the basis of this data, we can say that this model is not fitted well. So you have to change on it, we have to add some more variables in it, and we have to check that there is correlation, or we have to add some more factors, because check the coefficient of determination, that is adjusted R square or R square. Someone use the R square, someone use the adjusted R square, but adjusted R square is better. So here 0.444, we can say that 44.4%, only 44.4% variability explained by the model, explained the health score on the basis of age. So we can say that this model is not so well, not good, not fitted good. So we have to need some improvement in this data set. So this is the brief concept of the regression analysis. So thank you everyone, thank you. If you have any query, and sorry, I want to show you some how someone yesterday asked me about that, how to check the reliability and validity of the data set. Okay, reliability and validity of the data set. So how to check the reliability and validity of the questionnaire? Just suppose you have a questionnaire Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, and this is the total of your questionnaire, and you want to check that. And mostly in the research, once you submitted your research, your supervisor said that check your validity, check your reliability of your questionnaire or data set. Then how can we check that your data is reliable or not? Just go to analyze, go to scale, go to analyze, go to scale, and click on reliability. And you are interested in your questionnaire. How many questionnaires are there? There are how many questions are there? There are 8 questions. Just click on it, and you get Q1, Q2, Q3, Q4, Q5, Q6, Q7. 8 questions are need to be checked, and you want to check that they are reliable or not. Click on it, and you get, we use the Cronbach alpha test, and here just see it here 0.804. your Cronbach alpha test is 0.804. Suppose this is my questionnaire, and on the basis of this questionnaire, we get 0.804, which is close to 1. When your reliability statistic Cronbach alpha's value is close to 1 or greater than 0.6, we can say that your data is reliable, and you have to move, you have to proceed further for the analysis. That is 0.804, 0.6, 0.7, 0.8, 0.9. This is the good value and close to 1. When it is close to 1, that is your data will be reliable. So Cronbach alpha test is used for the to check the reliability statistics. Now, how to check the validity of your data set? How to check the validity? Validity means to check the validity, we perform the correlation test. Just see it, correlation, go to analyze, go to correlate, go to bivariate, reset it, and you have to just consider all the variables here, control A, in the variable section, and go to option, no need to check it other, click on it. Okay, to check the variability, question 1, question 2, question 3, question 4. Before checking the to check the validity, first you have to total all the scales variable in your data set, just like it here. This is Q1, Q2, Q3. There are 8 questions, and calculate the total of all the questions. 2, 3, 2, 3, 3, 1, 1, that is 18. This is the total. And now after that, you can use the correlation command, correlate command, go to analyze, go to correlate, go to bivariate, and click all the variables in it, including total, and click OK. And you get the correlation. And your data is valid or not, your questionnaire is valid or not. Check this value, check 0.001, 0.001. If this value is less than 0.05, remember, if this value significant two-tailed, this value is 0.005, sorry, 0.05. So if this value is less than 0.05, we can say that your data is, your questionnaire is, this question is valid. If it is not, then you have to change this question. You have to change or recheck this question. Here you have to check the value 0.001, means total. We use the total concept. We just check the validity through the total column. In total column, question 1 is 0.001. This value is less than 0.05. So we say that your this question is valid. Similarly, 0.032, we can say that question 2 is valid because 0.05 is greater than 0.032. So this is the concept of validity and reliability. So validity will be checked through correlation, and reliability will be checked through Cronbach alpha test. So thank you everyone, and if you have any question, please. Anyone?
Thank you, sir. Thank you very much.
Oh, is it audible, sir?
Yes, please.
Sir, once again, just to make us understand, if the value is 0.005, then this question will be valid.
Yes. If p value that is significant, just sit here Q1 and check in the total 0.001. 0.001 means your p value is less than 0.05. That means your question is valid. You have to move, proceed.
Right.
Okay.
Right.
Okay.
Thank you.
Yes, anyone?
Yes, kindly open your camera, please. Whenever you ask the question, kindly open your camera. Kindly open your camera, all of participants, please. We will take a screenshot. Sir, sir, sharing is completed or not?
Yes, pardon?
Sharing, screen sharing
No,
completed?
sharing is off. I think your PPT is over or session is over. So if you want to check anything, then I will share with you.
Please off the screen, sir, actually. Yes, yes. Okay. Thank you very much for everyone. Please open your camera. Kindly please open your camera. Today is the last day of this workshop. We will discuss a lot of things. We will know about your views. Yes.
Yes, someone asked about the standard deviation.
Yes, yes.
Standard deviation, there are two things are there. Standard deviation is for population, and standard error generally comes in the category for the sample. When we are talking about sampling distribution, means once we are dealing with the samples, then we are using the standard error, because standard error is nothing but standard error of any sample mean is equal to under root of variance of that variable. Similarly, standard deviation is sigma, variance sigma is denoted by sigma, and sigma is nothing but under root of variance. So once we are dealing with the standard deviation, we are dealing with population, and once we are dealing with sample, we use the concept standard error.
Yes, please kindly open your camera, all participants. I requested all participants, please kindly open your camera. Yes, yes.
Anyone else, please?
Yes. Yes.
Sir, can we get this video of this session?
Yes,
Yes,
yes, of course. We will provide by tomorrow, no? By tomorrow or after tomorrow. There is no problem.
Okay. Thank you, sir.
Okay. If I am requested of all participants, please, if you want to give your views regarding this workshop, kindly tell us. Give your feedback. Anyone can speak in any language. Yes. Siva Chandrajan, D. Puntoso, Sophia Shapakat, Del, HP, Himshika Singh, Nand Kishore, Archana Jana, Roshane. Yes, if you want to say something, kindly explain your views. Yes. Anyone want to say something?
Yes,
कोई भी
sir.
जो कुछ कहना चाहता है regarding
SPSS workshop. First time I attended this workshop, and it is very informative. It is very informative.
Sir, firstly, please kindly give your introduction. Actually, you are from.
Yes, I am Nandkishore. Sir, I am Nandkishore, and I am working in National Institute of Financial Management, Faridabad, as a senior library information assistant.
Yes, sir. Yes, sir. Continue, please continue.
Yes, sir. It is a very informative session, and I like very much it. And I first time using because of you SPSS, and I have downloaded, and I will try this as you inform us about it, and I will definitely use. Thank you, sir.
Thank you very much, Nandji. And anyone else? Yes. Shikaji, want to say something? Your experience actually regarding this workshop.
Yes, sir. My name is Himshika Singh, and I am pursuing PhD from Education Department, Aligarh Muslim University. And I have attended both the sessions of this workshop, and I found that is really a very relevant workshop and very informative session have been attended by all the researchers. And this is very relevant workshop related to the SPSS, and this is very informative. Thank you.
Thank you very much. Yes, anyone else? If there are any doubts regarding this SPSS, kindly mention your question in WhatsApp group or in email ID. No? Our resource person will reply of all your queries. Sir, I think we should end it. Right?
Yeah, sure.
Yes, yes. So first of all, I am thank you very much for of all participants. So I want to thanks my resource person, Dr. Azam. I would like to take the moment to express my sincere gratitude to the everyone. Firstly, I want to thank the Dr. Azam for sharing their knowledge and expertise with us. They have been encouraging and provided excellent support throughout the training, making it enjoyable and fruitful learning experience. My fellow trainees, thank you for all participants' engagement and willingness to learn alongside me. Your questions, comments, and feedback have been instrumental in creating collaborations and dynamic learning movement. Once again, thank you all for your contributions to this training program. I look forward to applying that what I have learned and to continuing to collaborate with all of you in the future. So thank you very much, everyone, for coming this session. And thank you, sir. Thank you, Sophia ji, and all of participants. If you want to say something regarding this conference, you can express your views. Otherwise, we will end it. No? We will send you certificate by tomorrow. No, participation
Okay.
registered email ID. I think we should end it, sir. No?
Yeah, yes, please. Thank you, everyone. Thank you. If you have any query, if you have, yes, you have any query, then you can contact me through mail. Feel free to contact me. I will sort out your issues, and please, you can contact me through mail. Okay.
Sir, I have one question, sir. I have one question there.
Yes.
Sir, I have all SPSS, and then I use like you are using this SPSS?
Your version is old. What
yes,
are you
sir.
saying? Yes, no need to change anything. Just updated some more new techniques are added once they update their versions. So if you have version 16 or 20 or 25, then no need to. If you have performed the basic statistics t-test or something rather than something else like ANOVA, then no need to change anything. Some brief changes are there. Some rare changes are there. So no need to change anything. Okay. Because it's a licensed version. You can download it through SPSS trial student version. Okay.
Okay. Thank you, sir.
Ruchi Khurana. Want to say something? Ruchi ji.
Sir, kindly arrange some more workshops in the future because this is very informative workshop and provides so many things and helps in my analysis. So
yes, we will. Yes, ma'am. Sure.
In future also.
We will conduct a 1 week workshop, and after a month or after a week.
Sure, I will try my best.
There is a 2 days only. There is a 2 days only. So
it is very difficult to summarize all these statistics in 2 hours. It is very difficult.
Thank you, sir.
Yes, Ruchi ma'am, want to say something? Ruchi ma'am is also here. Okay, Ruchi ma'am, actually.
Hello, good evening, sir.
Good evening, ma'am. Good evening.
हाँ सर, जो भी 2 दिन की वर्कशॉप में सर जो भी हमने जो टेस्ट है और जो हाइपोथेसिस के बारे में जाना, सर मुझे लग रहा है कि मेरे फर्दर वर्क में ये काफी हेल्पफुल रहेगी। एंड थैंक यू सर, जो भी आपने इतने ऐसे जस्ट एक 1 क्लिक पे एआई की मोड की भी जरूरत नहीं पड़ेगी सर, एकदम टिप्स पे आपने सारी चीजें हमें स्टार्ट से रिलेटेड मतलब 1-1.5 घंटे में आपने इतना कुछ बता दिया। थैंक यू सो मच सर। आप किसी एआई टूल से कम नहीं है सर।
It's my honor for me. I am also in a learning stage.
हाँ सर, learning is a continuous process, never ending.
Learning is a continuous process till death. For academician, you have to learn till death.
Yeah, sir. Thank you so much, sir. Thank you so much.
Thank you.
एक्चुअली मेरा लोगों से बार बार रिक्वेस्ट करने का मतलब यही है कि एक्चुअली द पार्टिसिपेंट स्पीक समथिंग है ना, एक्सप्रेस समथिंग। एक्चुअली उन लोगों ने ये 2 दिन में क्या सीखा, तो थोड़ा सा वो एक्सप्रेस करेंगे ना, तो बहुत सारी चीजें उनकी मतलब समझ में आएगी कि उनके माइंड में कुछ आया है या नहीं आया। तो विदाउट एनी हेजिटेशंस, तो प्लीज स्पीक एंड एक्सप्रेस योर व्यूज इन एनी लैंग्वेज। देयर इज नो लैंग्वेज बाउंडेशंस हियर, है ना। तो क्योंकि ऐसा होता है कि सब कुछ जानने के बाद भी लोगों को पता तो होता है, लेकिन वो लैंग्वेज की बाउंडेशन की वजह से वो बोल नहीं पाते। तो जो भी मतलब एक्सप्रेस कीजिए व्यूज, जो भी आपने सीखा, जो समझा, जो खामियां आपको नजर आई हैं, एडवांटेज जो आपको नजर आए, और हम क्या इम्प्रूव कर सकते हैं नेक्स्ट टाइम में। तो आपका जो फीडबैक होगा बहुत ही मतलब हमारे लिए बहुत वैल्यूएबल होगा, क्योंकि एक्चुअली मैंने इस बार आपको फीडबैक फॉर्म भरने को नहीं दिया। someone is asked about the feedback form, लेकिन मैं ये जानना चाहता हूँ कि लोग orally अपने व्यूज को एक्सप्रेस करें, है ना, अपने व्यूज को बताएं कि एग्जैक्टली कि व्हाट इज गोइंग ऑन इन देयर माइंड्स, है ना। तो ये जरूरी है। फीडबैक में तो भाई सब लोग कह देते हैं, सामने तो सब लोग कहते हैं अच्छा हुआ अच्छा हुआ अच्छा हुआ, लेकिन जब तक आपको आपके अंदर की कमी अगर आपको पता नहीं चलेगी ना, तो यू कांट इम्प्रूव योरसेल्फ। तो व्हेनेवर you have any complaint and any suggestions, kindly give your suggestion here. Yes, otherwise we will end it. Yes, anyone else? Parveen Kumar, Archana, Roshan, Shivanshi Singh, Amal, Asha Gosel, Tanya S. Nair, and lot of Parveen, Archana Jaina, Ashok. Okay. Thank you everyone for coming these wonderful sessions. And once again, Archana Jaina want to say something. Archana Jaina want to say something. Kindly arrange the recording R and Python program. Actually, we will provide the recording on all 2 sessions. I know. Yes. Archana Jaina want to say something. And Parveen Kumar want to say something. Ma'am, actually your voice is not. You are muted, ma'am. Ma'am, you are muted. Yes. Yes, ma'am. Yes. Yes, ma'am. Yes, ma'am. Want to say something? Your voice, you are muted, ma'am. Please unmute yourself. Okay, no problem. Now we will end it. Okay, sir. Thank you very much.
Thank you everyone. Thank you.
Dr. Mohammad Azam sir and everyone for coming these wonderful sessions. We will provide you certificate by tomorrow in your registered email ID. Thank you very much. If you have any queries, kindly mail us and WhatsApp us. Thank you very much. Thank you. Thank you very much.
Thank you.
Thank you everyone.